Hi, and welcome to the fourth of 5 videos for section 10.3. At the end of the last video, or in the third video, we were doing row-echelon form. In this one, we're going to look at what if it asks us about what is reduced row-echelon form. So let's say we have an example, and it says solve using reduced row-echelon form. And let's say that we have the same system we had before. 4x plus 8y minus 4z is 4. 3x plus 8y plus 5z equals negative 11. And minus 2x plus y plus 12z equals negative 17. So again, this is the example we had in video 3. We did row-echelon form. So we got it to a form where it looked like 1, 2, negative 1, 1, 0, 1, 4, negative 7, and 0, 0, 1, negative 2. Now remember what the difference is between row-echelon form, which is this, 1 on the diagonals, zeros in the lower corner, versus reduced row-echelon form. In reduced row-echelon form, we now want to work, so before we work from the top down, now that we get it to row-echelon form, we're going to work from the bottom up, because now we want to get this section of the matrix to be all zeros. Reason being, once we do that, all we're going to have is ones on the diagonals, so these values are simply our solutions. It avoids the necessity to do back substitution. So let's start working with row 3 to get a 0 in this position here where there's currently a 4. So I have to do what? So just as I did before, I'm going to track what I'm doing. So I have 0, 0, 1, negative 2. So what am I doing? I'm multiplying row 3 times negative 4. Add that to row 2. That gives me a new row 2. And again, I keep track of this so then if I make a mistake, I can go back and check my math. So if I do that, if I'm multiplying this by negative 4, what do I get? 0 times negative 4 is 0 plus 0, still stays a 0, as it should be. We don't want to add numbers back in here now. So if you find yourself changing a 1 or changing a 0, there's something going on with your matrix. You're following the wrong process. So if we have negative 4 times 0 is 0, plus 1 is 1. Negative 4 times 1 is negative 4, plus 4 is 0. Negative 4 times negative 2 is positive 8. 8 minus 7 is 1. Now do the same thing again with row 3, trying to get rid of the value in row 1. Just as we did before, we used row 1 on row 2, and then row 1 on row 3, and then 2 on 3. Now we're reversing the process. Row 3 on row 2, row 3 on row 1, and then we'll do row 2 on row 1 to finish it off. So, what do I need to multiply now to get a 0 in this position? Well, I just have to multiply by 1, right? Because 1 times 1 is 1, minus 1 is 0. So I'm doing row 3, if you want to say times 1 plus row 1, gives me a new row 1. So I'm basically just adding row 3 to row 1. So 0 plus 1, 1. 0 plus 2, 2. 1 plus negative 1, 0. Negative 2 plus 1 is a negative 1. Lastly, we're almost there. We need to get a 0 in this position, so I'm going to use row 2. So, leave row 2 and 3 alone. 0, 1, 0, 1. And 0, 0, 1, negative 2. So I need to do what? I need to multiply row 2 by a negative 2. That way when I add it here, it gives me 0. So I have row 2 times negative 2 plus row 1 gives me a new row 1. So negative 2 times 0 is 0 plus 1 is 1. Negative 2 times 1 is negative 2, plus 2 is 0. Negative 2 times 0 is 0, plus 0 is 0. Again, remember, if we start getting numbers back where we'd already had a 0, we have an issue there. And then negative 2 times negative 1 is negative 2, minus 1 is negative 3. So this is now in reduced row echelon form. We have 1s on the diagonal, 0s above and below that leading entry of 1. So remember what this means. This is my x column, this is my y column, this is my z, these are my constants. So this really means what? X is negative 3, y is 1, z is negative 2, which when I put it in the form here, the triplet, negative 3, 1, negative 2, which is the same answer that we had when we did it in row echelon form and used back substitution. So that's it. A couple more steps avoids us with the messy back substitution. This is reduced row echelon form, and whatever values we end up with in the final column are the answers to the system. So that wraps up video 4. Come on back, we'll look at video 5, which is a couple of special cases that we may run into when we're solving these systems of linear equations.